Hello, I'm Dr. Wang. Here is the question. How to simplify nested square roots like this kind of questions? We are going to introduce a general result with a simple proof. We use this result to solve 6 questions. We're trying to cover different important situations, including the fourth root. Here is the result. For given nested square roots in this kind of format, x plus minus 2 square root of y. Both x and y are natural numbers. That means x and y are positive integers. Pay attention here. X, here plus minus, here's 2 only. Square root of y. For given this kind nested square roots, if exists positive integer a and b such that this system has a solution, the positive integer solution a and b satisfy this kind of system. This means this system has a positive solution a and b. Then we have the following result. We can simplify the given nested square roots as absolute value of square root of a plus minus square root of b. If here's plus, here we use plus. Here's minus, we use minus. This is the result we are going to use to solve those questions. Simple proof. We prove this result in the backwards. If this is true, we want to prove this is true. The logic from this result is, if this is true, we imply this is true. Now we can prove this way, backwards. If this is true, can you imply this is true? All are if and only if conditions. If this is true, we can square both sides. Square both sides, that means the left-hand side, the square root was canceled. The right-hand side, that's a square. Simplify, we have a plus b, then plus minus 2 times square root of a, b. We compare both sides of this equation. We have a plus b equals x. Then we have plus minus, 2, we have 2 here. Square root. Inside part, that's y. So y equals ab. We imply this is true. We can prove this way. If this is true, we can imply this is true. This is true. We have done the proof. Now we are going to use this result to solve questions. Look at the first example. Square root of 3 plus 2 times square root of 2. Does this match the given format? Yes. X equals 3, y equals 2. So we have 2 here. Here we use plus. When you solve this system to find the positive integer solution, A and B. It's easy to see that. The answer is A equals 1, B equals 2, or A equals 2, B equals 1. Because in this result, A and B are symmetric. It doesn't matter. We only need to use one solution because here always it's the same. Square root of A plus minus square root of B. Whatever B first, A first, we always consider absolute value. The answer should be same if we use the first solution or second set of solution. It doesn't matter. So here we can go back, use the solution. This, here we use plus. So inside of the absolute value, we use plus. Square root of A plus square root of B. Square root of 1 plus square root of 2, which is 1 plus square root of 2. This is the answer for example 1. Let's look at the second example. Square root of 5 minus square root of 24. Does this match this format? X, we have 5 minus, we have minus here, but we don't have 2 outside of the square root of y. Can we solve this problem? Modify this to fit this format. Inside part of the square root of 24. 24 is 4 times 6. Square root of 4 is 2. 2 times square root of 6. This part is fitting, matching this given format. X equals 5, Y equals 6. Here is minus. We use minus here. What do we need to find now? We want to find A and B. Solve this system. A plus B equals 5. A times B equals 6. So you can see A equals 2, B equals 3. Or A equals 3, B equals 2. Use this result again. Square root of A is square root of 2. Minus square root of B is square root of 3. We consider the absolute value. Because the square root of 3 is bigger than square root of 2, we put the square root of 3 first. Square root of 3 minus square root of 2 is the answer for example 2. Example 3. This given question looks not fitting the given format. Here should be 2, but here we have 4 here. 4 equals 2 times 2. We have 1 extra 2. We can put the extra 2 inside of the square root, which is 4. 4 times 5 is 20. Now we can see this part matches the given format. X equals 9. Here we have minus 2. Y equals 20. We solve this we solve this system to find A and B, the positive solution. We can see that one is 4, one is 5. Or A equals 5, B equals 4. We can use this result absolute value of square root of A. Here is minus square root of B. Use this set or this set, it doesn't matter. Square root of 4 minus square root of 5, because that's absolute value. Square root of 5 should be first, minus square root of 4. Square root of 4 equals 2. Square root of 5 minus square root of 2 is the answer for example 3. Example 4. Square root of 2 plus square root of 3. It does not match the given format. We don't have 2 here. How to get 2? We cannot get 2 from the inside of the square root. What should we do? We can do the following. Both numerator and denominator times 2. 2 times 2, that's 4. Square root of 3 times 2, that's 2 square root of 3. Separate the square root into 2 parts. Square root of 4 plus 2 square root of 3. Then divide by square root of 3. We can simplify the numerator. Use this result. The numerator does match this given format. We have 2 here. Considering the numerator only, x equals 4, y equals 3. We simplify the numerator first. Solve this system. We can easily see that a equals 1, b equals 3, or b equals 1, b equals 1, a equals 3. We can plug in this format. Square root of 2 plus square root of 3 equals square root of 4 plus 2 times the square root of 3. Divide by square root of 2. The numerator, we have the a and the b here. The numerator equals absolute value of square root of 1 plus square root of 3, or square root of 3 plus 1. How to get rid of the square root from the denominator? Both numerator and denominator times square root of 2. We have 2 here. Square root of 3 times square root of 2 equals square root of 6. Square root of 1 times square root of 2 is square root of 2. This is the answer. Example 5. Look at this example. This does match the given format. We want to solve this system. X equals 1, y equals 3. Solve this system. We cannot see the positive integer solution. We replace b in terms of a. From the second equation, b equals 3 over a. Replace b in the first equation. A plus 3 over a equals 1. How to get rid of 1 from the denominator? Both sides times a. A times a, that's a squared. A times 3 over a, that's 3. A times 1 is a. Move a to the left-hand side. This is a quadratic equation. If you use quadratic formula, you can find this quadratic equation has no real solution. So here, from this result, we want to find positive integer solution. So from this example, because it has no real root, we imply this method does not work for this question. In general, we can claim this method is not always working. For some examples, it works. For some examples, it don't work. Look at last example. We have the fourth root of 7 minus square root of 84. I have a different video discuss the similar question, square root of fourth root of 7 plus square root of 48. Use a different method. Certainly, this method also can apply to that question. Now, how to solve this question using this result? Here, that's fourth root. Our result is only what for square root. Fourth root, we can consider square root of square root. So we consider the square root of 7 minus 48 first. The square root. Original question is fourth root. We find the square root first. Square root does not match this given format. We can factor 2 out to match this format. 48 equals 4 times 12. Square root of 4 is 2. So now this one is matching this format. X equals 7. Here's minus 2. Y is 12. Solve this equation. Solve this system. We can see A equals 3, B equals 4. Or A equals 4, B equals 3. Use this result. We have absolute value of square root of 3. Here's minus, we use minus square root of 4. Because the absolute value, we put the big number first. Square root of 4 minus square root of 3, which is 2 minus square root of 3. This is the answer for square root of 7 minus square root of 48. Our question is the fourth root. The fourth root, we can rewrite it as square root of square root. The inside part, we can use this result, 2 minus square root of 3. Now we are here. Does this match the given format? No, we don't have 2 here. What can we do? Both numerator and denominator from the inside times 2. Then we have 2 here. Separate into 2 parts. We consider the numerator first to apply this result. The numerator, we can see x equals 4, y equals 3, yes, minus. Solve this system. We find a equals 1, b equals 3, or a equals 3, b equals 1. We have the result for the numerator, which is square root of 3 minus 1. Replace this part by square root of 3 minus 1. We replace it. We have square root in the denominator. How to get rid of the square root? Both numerator and denominator times square root of 2. Then we have square root of 3 times square root of 2 is square root of 6 minus 1 times the square root of 2, that's square root of 2. Square root of 6 minus square root of 2 over 2 is the final answer. That's all for today. Thanks for watching and see you next time.